In this video, we're going to look at geometric sequences. So let me just give you an example of a geometric sequence. Basically, a geometric sequence is when a term is multiplied, or the previous term is multiplied by a common ratio. So let's multiply this by 3. So we get 6 as the next term. Multiply the previous term by 3, and we get 18 as the next term, and so on. Okay, that's a geometric sequence. We can write this as, if we're writing it as a recurrent relation, we can say that the next term, or the current term, is the previous term multiplied by a common ratio, which we'll say is r. We can also say, if we let a equal the first term, and r being this common ratio, which is the multiplier between the first and the second term, and the second term and the third term, and each successive term, as being, I suppose, this term divided by that term. That's how you'd find it. We can write a rule for the term as the first term multiplied by the ratio to a power. And we're using the power of the previous term, so it's n minus 1. And don't forget, this common ratio r can be found by taking the next term, so t to the n plus 1, divided by t to the n, and that will tell us what the common ratio is. Let's do an example where we are looking for the first and the common ratio of a geometric sequence. So I've written this example up. We're going to find the 10th term of this geometric sequence that we were just talking about, 2, 6, 18. So the first thing we need to do is identify that a is 2, and that the common ratio we can find by taking any two successive terms. So let's just do the first and the second. We'll just do 6 divided by 2. Tell us that the common ratio is 3. That means we multiply each of the terms by 3 to get the next term. If I'm going to find the 10th term, I'm going to find for when n equals 10. So let's use that relation that we just wrote down. So Tn equals a r to the n minus 1. Now let's substitute these values in. So the 10th term is 2 multiplied by 3 to the power of 10 minus 1, which is 9. So I'll work that out. Obviously, I need a calculator to work that out. It becomes quite big, as 39,366. All right, you are expecting quite big numbers because it's being multiplied. These are exponential relationships. Now we're going to look at an example where we've been given the first term. So if a is 18, if the first term is 18 and the fourth term is 144, find the common ratio r. So what we're going to do is we're going to use the rule that we've got, which is Tn equals ar n minus 1. I'm going to substitute the values in. We know that the first term is 18, so we use that for a, and we know the fourth term, so T4, so I'm going to put 144 when n equals 4, is 18 multiplied by r, which we don't know, to the power of term 4 minus 1 is 3. So it's 144 equals 18r cubed. 144 divided by the 18 will tell me what r cubed is. Well, that's 8. 8 equals r cubed, and then I just need to cube root 8 to find the common ratio r. So the cube root of 8 is 2. So therefore, the common ratio for this sequence is 2. I'm going to run through this example now, where if you've got this geometric sequence here, so we've got 36, 18, 9, and so on, and we've also been given that the nth term is 9 over 16. We've got to find out what's the term number, what's n. So for this, the first thing we need to do is write down what a and r is. So a is 36, that's the first term of this sequence, and r is found by dividing the second term by the first term. Obviously I could do the third by the second, but I'm just going to go for 18 divided by 36. That tells me that the common ratio is 1/2. I'm going to substitute this into the formula Tn equals ar to the power n minus 1. So let's have a look what we've got. We've got a value, 9 over 16, equals the first term, which is 36, to the multiplied by 1/2 to the power of n minus 1. With this, I'm going to divide this fraction by 36. Dividing that by 36 gives me 1 over 64, which is equal to 1/2 to the power n minus 1. If I then look at 64 as a base of 2, because what I need to do is I need to equate this side with this side, because at the moment we don't have any method of solving an unknown power. So what we need to do is look at this and go, well, 64 is 2 to the power 6. 1 to the power 6 is also 1. So I can write that as 1 to the power 6 over 2 to the power 6, which is the same as a half to the power n minus 1. Now, writing this, I've now got the same base to the power of 6. And because the bases for these powers are identical, I can now say, therefore, 6 equals n minus 1. Therefore, adding 1 tells me that n equals 7. Now, there is an alternative way that we can find an unknown power, and that's by taking logs to the base 10 of both sides. Not sure that we've studied that in maths methods, so we'll just go with this at the moment. And then you can always watch my videos on logs later on.